All right, in this part, we're going to take a look, you guys, at polar graphs. Okay, so what we're going to do is we're going to make a table of values, plot the points, kind of get a feel for it, and then we'll look at converting it to rectangular equations for the ones that we have, and kind of verifying our graph. Okay, so here's our first one. Graph the curve of the polar equation, identify the curve, and rewrite the equation in rectangular coordinates. So r equals 2. So number one, let's make this table. And now normally we have a theta involved with this. R is usually defined in terms of theta, but here we have no theta. So we know R is always 2. It's always 2. It doesn't matter what your theta is. So we're just going to start picking some thetas, some angles. I'm going to start out with an angle of 0, and then let me go with like a theta being pi 6, and then the old pi 4ths, and then the old pi 3rds, and then the old pi halves. And so I've got a bunch of points here. Here's my polar coordinates. I got 2, 0. These are all r theta. I got 2, pi 6. Again, these are all r theta. I got 2, pi 4ths, and so on, right? So let's graph these and let's take a look at the behavior here. If I do not rotate, so theta is 0, and I go out 2, I'd be right there. Now I rotate pi 6. Here's the pi 6, but I got to go out 2, right? Now I rotate pi 4ths. I go out 2. Now I rotate pi 3rds. I go out 2. Now I rotate pi halves, which is on the y-axis, and I go out 2. And I could keep doing this, right? And what am I going to see? Exactly. You're going to see a circle. You get that point, and that point, and that point, and that point, and so on. And like, oh, I got a circle. Well, let's verify that. So that's step 2. How about let's convert to a rectangular equation. We know r is 2, right? And I know r squared is x squared plus y squared. So what I'm going to do is I'm going to actually square both sides here. Square and square. So I have r squared, and I know r squared is x squared plus y squared equals 4. And so this is the equation. Let me write the standard form for the equation of a circle. So I have a center HK. My center is at 0, 0. My radius, since radius squared is 4, my radius must be 2. So I have a circle with radius 2. Circle centered. You know, I could draw that again, of course. Circle centered. There's our circle. Centered at 0, 0. Radius 2, right? And of course, I'd fill this thing in. We were graphing points, plotting points to kind of see it with our polar coordinates there. And so this r equals 2. R equals 2, this polar equation. Is a circle centered 0, 0, the radius 2. Well, that's not the only one. You could, r equals negative 2 is the same thing. That polar equation is the same thing. All right, so how about this polar equation? We just got theta this time. Theta is only pi 3rds. So theta is always, so we're going to plot some points theta r. Theta is always pi 3rds, regardless of the r. So let's let r be 0, then we'll let r be 1, 2, 3. How about -1, -2, -3? And let's graph. Let's plot those points. All right, so if I do not rotate, so r is 0, but I'm sorry, my rotation is pi thirds, but I don't go anywhere, right? No distance from the origin. My next one, again, this is r theta. My next one is 1 pi thirds. So here's my next r theta. So I'm going out, bless you, again, I'm going pi thirds. Here's my pi thirds. I'm going out 1. There's that point. Now I'm going out I'm still rotating pi thirds, but I'm going out 2 this time. Next point, I'm going out 3 this time, right? Now let me do the -1 pi thirds. R is -1. Well, now I got to go in the opposite direction. 1. All right, rotate pi thirds, but I went in the opposite direction. -2 pi thirds, opposite direction 2, and so on. And soon enough, you're like, oh, what do I have? This is a line. This is a line. Well, let's convert it. We know tangent of theta is y over x. Well, we have our theta is always pi thirds. Well, the sine of pi thirds is √3 over 2. Cosine of pi thirds is 1/2. So that's just √3. Now let's solve for y. So let's multiply both sides by x. So I have √3x. So there's my slope of the line. I'm going up √3 and over 1, right? Y equals mx plus b. My y-intercept is 0. So lines can also, and circles, right? We talked about circles, can have more than one equation. Polar equation, I should say. So this one was theta being pi thirds, but you do 4 pi thirds would be that same line, and about -2 pi thirds are all that same line. This time we got r equals secant, or 1 over the cosine, same thing. And let's go ahead and make our table of values with theta and r. Pi 6, let's go pi 4, pi thirds, pi halves. Let's just jump to 2 pi thirds and pi. That'll give us a few. All right. I'm punching these in one by one. So I got 1 over cosine of 0. I know the cosine of 0 is 1, so there's the first one. Let's do the next one. R equals 1 over cosine of pi 6. I know the cosine of pi 6 is √3 over 2, so I got 2 over √3, or 2 √3 over 3. Which, by the way, that's 1.15. Then I got 1 over cosine pi 4, so 1 over √2 over 2, which is √2, which is 1.414. And I got 1 over cosine of pi thirds. Well, cosine of pi thirds is 1/2, so 1 over 1/2 is 2. And I got 1 over cosine of pi halves. Well, the cosine of pi halves is 0. 1 over 0, I can't do that, so that's undefined. And then I've got, let me erase this so I have some room for my 1 over cosine 2 pi thirds. Well, cosine of 2 pi thirds is negative a half, so 1 over negative a half is negative 2. 1 over the cosine of pi is negative 1. 1 over negative 1, negative 1. So here's a few points. Let's go ahead and graph them. R comma theta. So the first one, my R is 1, my theta is 0. I do not rotate, but I go out a distance of 1. Now the next one is pi 6. So my R is 2 root 3 over 3, or 1.15, and I'm rotating pi 6. So about right there. Now I'm going out, I'm rotating pi fourths, right? Pi fourths, but I'm going out 1.414, so I'm about right there. Oops. And then I'll go out pi thirds, and I'm going out 2, so I'm about right there. Pi halves is undefined. And I rotate 2 pi thirds. Well, 2 pi thirds, 120 degrees. I'm over here, but I got to go out negative 2. So 1, 2. So I'm about right here. So keep erasing that. Pi, rotate pi 180 degrees, but then I go in the opposite direction, negative 1, so I end up right there again. Oops. Anyways, we could keep going with this, but hopefully you see that's a vertical line, and we'll go ahead and we'll verify that. So we could convert to step 3, polar to rectangular. And remember, we have x equals r cosine theta, y equals r sine theta. You know, we could even convert our polar coordinates, r theta, with this. Like, for example, 1, 0. What would the x, y be? So I'd plug that in. I'd get 1, 0. The next one was 2 root 3 over 3 and pi 6. So if I went x equals r cosine pi 6, I'd find the cosine of pi 6. And so I'd have 2's cancel, and I have 3 over 3. So I'd have 1. And then I'd do the same thing for the r sine of theta. So then I'd have 2 root 3 over 3 sine pi 6, right? And anyways, I'd get root 3 over 3. So I'd give you a few of these. The r comma pi fourths would give you 1 comma 1. The 2 comma pi thirds r comma theta would give you 1 root 3 for the xy. The negative 2 pi thirds r theta gives you 1 negative root 3. The negative 1 pi, plugging it into those, gives you 1 comma 0, right? So you can see how that x value is always 1 there. So you can do that. I know it's very tedious. I don't know that you really want to, but you can, right? If you wanted to convert all those r thetas to xy's, you could, if you wanted to. But let's convert to a rectangular equation. We have r equals the secant of theta. We know the secant's 1 over cosine. Let's go ahead and multiply both sides by cosine. So we have r cosine theta. Well, we know x equals r cosine theta. There it is. There's that vertical line, x equaling 1. So find two polar equations for a circle of radius 1. If you remember back, we had r equaling 1 would be radius of 1 centered at 0, radius of 1. So you could also have r being negative 1. That's another one, centered at 0, radius of 1. Let's go ahead and graph this polar equation. If you got theta equaling a number, hopefully remember that's going to be a line for you, right? And so the first thing is you can make a table with theta r. with a bunch of pi 6. Theta is always pi 6, pi 6, pi 6. Pick some r's. Maybe you do plus minus 1 this time. Go ahead and graph those. So pi 6, but I don't go anywhere. Pi 6, I rotate pi 6. I go out 1. There, it's right there. And if r is negative 1, I'd go out this way 1. Right? Rotate pi 6 and go out 2. What if r is negative 2? I'd go right there. Rotate pi 6, go out 3. How about if r is negative 3? Right there. Anyways, start seeing that line. So convert to rectangular equation here, with theta being pi 6. I know the tangent of theta is y over x. So I get the tangent of pi 6 is y over x. So that's 1/2 over root 3 over 2. Sine of pi 6 is half. Cosine of pi 6 is root 3 over 2. So I got 1 over root 3 equals y over x. Multiply both sides by x. I got 1 over root 3x. Or we probably should rationalize that. That's root 3 over 3x. So my slope is root 3 over 3. So theta being pi 6 is that line. But note, theta could be 7 pi 6 would also be that same line. And about negative 5 pi 6 are also polar equations for the same line. So with Desmos, you could do this with Desmos, you guys. You can use a polar grid if you want, or you don't have to. Here's just a ripped image of me putting in 3 different polar equations here. R equal 3, you can see that red circle with a radius of 3. You get the cosecant there in blue, that line. And then 2 cosine of theta plus 1. We'll talk about those interestingly enough. But you've got R as defined in terms of theta, right? So if you punch it in with R and theta, it'll help you graph it and look at it, verify your graph. So let's do one here. How about R equals 4 sine of theta? Let's pick some thetas. How about 0, pi 6, pi 4s, pi thirds. Let's go pi halves. Let's do a few more here. 2 pi thirds. And we'll just throw them in one by one. Sine of 0, 0. 0 times the 4 in front, 0. Sine of pi 6, right? I'm finding 4 sine. Now I'm plugging in the pi 6. So I got 4. I know the sine of pi 6 is a half. So that'll end up being 2. My R is 2. Sine of pi 4 is root 2 over 2. So 4 times root 2 over 2 is 4 root 2 over 2. So I get 2 root 2, which is about 2.8. I plug in pi thirds, I get the sine of pi thirds. I multiply by the 4 in front, so I get 2 root 3. Sine of pi halves, which is 1. 1 times the 4 in front is 4. And so on. There's some of these here. So these are some real nice points. 0, 2, pi 6, 2. Pi has 4. Maybe I'll do that one. Maybe I'll do that one. I got 0, 0 right there. pi 6 comma 2 right there. Pi halves, I rotate pi halves, I go up out 4. That'd be right there. Rotate 3 pi 4s. Rotate 3 pi 4s, I go out 2.8. About ish right there. Rotate pi, I'm back at 0. You could do a few more of these, 5 pi 6, I'm out 2. I'd probably want to do a few more of these, but anyways, the rectangular equation is really going to help you to kind of see this on this one. So let's go ahead and put it in a rectangular equation form. We've got r equaling 4 sine of theta. Let me go ahead and multiply both sides by r. So I've got r squared equals 4r sine theta. Well, I know r squared is x squared plus y squared. And I know r sine theta is y. So I have x squared plus y squared equals 4y. Let me go ahead and complete the square on this so you can kind of see what this is. I'm going to take my b term divided by 2. Negative 2 squared is 4. I need to add in a 4 on both sides so that this factors perfectly into a perfect square. Now maybe you see that this is a circle centered. The center of the circle at HK is 0, 2. And the radius is 2. So that's my equation. This is not incorrect. That x squared plus y squared is 4y. It's just hard to recognize that that's a circle right there. Or maybe it's hard for you to recognize that that's a circle. But either way, this is a circle. So when you got r equals 4 sine of theta, you ended up having a circle there. All right, so for the special polar graphs, I want you to kind of look at the pattern you have and look at your handout. So 4 cosine 2 theta. All right, that's our first one. So you look at your handout, you're like, hey, I got 4 cosine 2 theta. Well, that would be right there. All right, so that'd be a rose curve that's symmetric about the x-axis. So if I go back, that would be this one right here. This is the A. This is my rose curve. Symmetric about the x-axis, right? Symmetric meaning it's got this point here, then it's going to have that point on the other side of the x-axis too, right? Let's look at the 4, how about the B? 4 cosine 3 theta. So I look back, this 4 cosine 3 theta. I'm like, that would be right there. My A is 4 cosine 3 theta. And I'm matching that graph. So this is a B. Oops. R equals 4 cosine 3 theta. So this is a rose curve. Symmetric about the x-axis. That's kind of how you're thinking about these, right? Like this is C, R is 1 plus 3 sine theta. Oops. There we are. We got a limicon. 1 plus 3 sine theta. So that'll be a limicon. It's symmetric about the y-axis as well. This was C. Symmetric about the y-axis with an inner loop here. And so on. This one and this one would end up being our D. And this one's the R squared equals 4 cosine 2 theta. This is the lemniscate. All right, let's look at this next one. We've got negative 1 equals r sine theta. We're trying to put this into Cartesian. Well, we know r sine theta is y. So this is just y equals negative 1. This is just a line, horizontal line, y equals negative 1. R equals 3. Well, if r equals 3, we're going to go ahead and we're going to square both sides here, because we know x squared plus y squared equals r squared. So this is a circle centered at 0, 0 with a radius of 3. How about this one? R equals 6 cosine theta minus 8 sine theta. So here, let me write it first. I'm going to go ahead and multiply both sides by r this time. And so I've got r squared equals 6r cosine theta minus 8r sine theta. Well, r squared is x squared plus y squared. R cosine theta is x. R sine theta is y. And maybe you're not totally sure what that is. This is your rectangular equation. But let me gather all my x's on one side, leave a space. Gather all my y's on one side, leave a space. Equals 0. And let me complete the square. So I take negative 6 over 2 is negative 3 squared is 9. I got to add 9 to both sides to make that a perfect square. Here I take 8 over 2 squared, which is 16 to both sides. That'll make that one a perfect square. So I get x minus 3 squared plus y plus 4 squared equals 25. So this is a circle centered at 3, negative 4 with a radius of 5. And that's your rectangular equation for that. These are good you try it problems as well. If you want to give these a go, that'd be awesome. Go ahead and multiply both sides by that sine theta minus 2 cosine theta. And take that r through. That's y. That's x. Let's see how we got y equals 2x plus 5. So this is just a line. R squared equals 4r sine theta. Well, x squared plus y squared is r squared. R sine theta is the y. So let's go ahead and complete the square. This is another circle. Center is 0, 2 with a radius of 2. Again, that's also correct. That x squared plus y squared is 4y. Here I would use your double angle formula on this sine of 2 theta. So you got r squared times 2 sine theta cosine theta equals 2. And notice your 2's, get rid of those 2's right there. So you got r squared sine theta cosine theta equals 1. Let me write that as r sine theta and r cosine theta. So y times x equals 1. Divide both sides by x. So you've got this rational function y equals 1 over x. We know x equals, if we're converting to polar, we know x is r cosine theta. Solve for r, 7 over cosine, so 7 secant theta. Again, this is a vertical line. Here we've got another line, right? We could solve for y if we wanted to and see that's a line, but let's go ahead and replace x with r cosine theta, r sine theta for y equals 3. Let's factor out an r. We're going to solve for r. So r equals 3 over cosine theta minus sine theta. So again, this is a line as well. Got y squared. Y is r sine theta. X is r cosine theta. So we got r squared sine squared theta equals 4r cosine theta. Go ahead and get rid of the r there. So we've got r sine squared equals 4 cosine. Let me divide by sine squared. Oops. So my r is 4 cosine over a sine times another 1 over sine. So my r is 4 cotangent cosecant. And by the way, what was this? Well, this is a parabola that opens to the right, right? Y is being squared. It opens right. When you're punching this into decimals, put parentheses around your cotangent of theta and your cosecant of theta if you want to take a look at that. Here, I'd probably expand this. Y minus 2 is a y squared minus 4y plus 4 equals 4. See how my 4's are gone here? And the reason I'm doing this, and let me also add the 4y to the other side. See how I got x squared plus y squared? So there's my r squared. It's 4y. Well, my y is r sine theta. Let me get rid of the r. So my r is 4 sine of theta. And we know this originally was a circle. It was centered at 0, 2 with a radius of 2. So that's what r equals 4 sine of theta would be. And that'll kind of get you going with polar coordinates and polar graphs. And appreciate you taking the time to take notes. See you next time.